Parts and whole. The first section of this module focused on number sense. Developing a strong sense of number concepts is important for future mathematical skills. In the next few topics, we will look at how place value and number concepts assist students with the 4 basic math operations in the early and elementary years. And those operations are addition, subtraction, multiplication, and division. We're going to start by looking at how numbers can be broken into parts. Look at the apple that's given below. We can actually cut it into parts and then put it back together to make the apple whole again. So here's one part, here's another, and here's the last part. So we broke this into multiple parts, and then if we bring them back together, we're going to end up having the whole apple again. Just as we can split an apple into parts, we can split a group of objects into parts. If we can move the children below to form 2 groups or parts. And we're going to make sure that there are the same amount of people in each part. So let's make one group there, one group there. 2, 2. So we have, if we do 2 equal groups, we have 3 in each group. And we can also, again, put them back together to make the whole line again. A whole can be one thing that can be broken into 2 parts. As shown here, this apple, if you slice it down the middle and you open it, you can look at both halves. Or a whole can be a group of things that can be broken down into smaller parts. So in this original triangle of apples, we have 6 of them, and you can break 6 down into 4 and 2 as an example. There are 7 counters in the whole, shown in the diagram below. Drag some to each part, and then we'll see how many are in each part. So if I bring 1, 2, 3, 4 into this part, and I can bring 3 into this part, we can see that 4 and 3 together makes 7. So 4 plus 3 equals 7. We could also change this, and we can show that 5 plus 2, still 2 parts, add up to the whole, or 7. Many other examples can be used here and shown. There are 7 counters in one part, shown here on the left and the bottom, and 3 in the other, over here to the right. If we drag all the counters into the whole, how many will we have in all? Well, let's actually find out, and we can count along the way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the whole amount, which is also the sum of 7 and 3, is 10. How do you think parts and whole relate to the 4 basic math operations? Take a moment to pause this video and think about it, write down your thoughts, and when you're done, unpause it, and we'll go through explaining how parts and whole are related to the 4 basic math operations. In addition, the 2 parts are called the addends, in this example 7 and 4, and the whole is called the sum. So the 2 parts or addends add up to equal the entire thing or the sum. Addition sentences can also be written from top to bottom or vertically. where you have the two addends directly on top of one another, a plus sign next to the bottom of those two numbers, draw a straight line underneath, and then the sum is found directly below that straight line, which represents the equal sign. When we subtract, we break a whole into two smaller parts. So we have a total of 7 baseballs in this whole group, and we can split it up into 2 parts. So let's say we had 2 in the first part and 5 in the second part. So you could have 7 minus 2 equals 5. That's not the only way that you can do it either. You could also show maybe you have 7 baseballs at the original set, and you break that down into 4 and 3. So 7 minus 4 gives you 3. There are a variety of ways that you can break down the entire group of baseballs or whatever objects you're dealing with into smaller parts to show that subtraction. A subtraction sentence has 2 parts, as well as a minus sign, an equal sign, and a whole. It begins with the whole, which is the biggest number that you have there. Then you have the minus sign, and then one of the parts. So we have 8 minus 2. Then we have the equal sign, and then we have the difference, which is 6, which is the other part, because 6 plus 2, the 2 parts, will add up to equal the whole. So the whole minus 1 part will give you, or be equal to, the other part. In a subtraction sentence, the first number is the largest number. It's called the minuend. The second number tells us how many we are taking away, and this is called the subtrahend. The answer is called the difference. The difference will always be less than the minuend. In our example, we have 8 minus 6 equals 2, and we can see how 2, the difference, is definitely less than the minuend of 8. Similar to addition sentences, subtraction sentences can also be written top to bottom. We have this first subtraction sentence written horizontally as 11 minus 7 is equal to 4. We can write the first term, or the minuend, 11, on top, and then minus the subtrahend, 7, and then instead of equal to, we draw the line, which signifies is equal to, and we end up getting the difference of 4. Multiplication is also associated with the part-whole model. When given the number of equal parts and the number in each part, we can multiply them in order to find the whole thing. So in this diagram, we have 5 equal groups with 3 stars in each. So if we bring all of our stars into the whole, that entire whole value will be equal to the number of stars in each group times the number of groups. And we'll actually show it. So we have 3 stars in this group. So if I pull each star in here, there's 3. My second group of 3, I can pull my stars in. My third group of 3, fourth group of 3, and the last group of 3, or fifth group of 3. And by doing this, we end up having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 stars, which is what 5 times 3 is equal to. In a multiplication sentence, we have factors, which are the numbers that are being multiplied together, and they are known as the parts, which are 3 and 2 in this example. And the answer is called the product. This represents the whole. So we have 3 times 2 is equal to 6, or the product of 3 and 2 is 6 is another way that it can be read. Similarly, you can write it by switching around what's given on both sides of the equal sign and write it as 6 is equal to 3 times 2, or 6 is the product of 3 and 2, where the product is equal to the multiplication of its two factors. When given the number of equal parts and the whole, we can divide to find the number in each part. Also, when given the number in each part and the whole, we can divide to find the number of parts. What we have here is we have the whole group that consists of 24 hearts, and we have 6 equal groups. So let's see how many hearts will fit in each group. So I can drag 1, 2, 3, 4. Let me try the next one and see if that helps. There's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we can see that we moved every heart into 6 equal groups of 4. So 24 divided by 6 is equal to 4 because there are 4 hearts in each group. When reading division sentences, we have 3 main components. One component is called the divisor, or the number that divides another number. The divisor is one of the 2 parts. Another term is called the dividend, which is the number that is being divided. The dividend is typically the largest number in your fact family, and this represents the whole. The quotient is the answer to a division problem. It is the second part of the division sentence. And division problems or sentences can be shown in 3 ways. The divisor is shown in purple in each one. The dividend is in green, and the quotient is in red. So 16 can be divided by 2 to give us 8. And again, it's read as 16 divided by 2 is equal to 8. And a fraction bar is also considered to be division, so that's what this last one represents. 16 divided by, using the fraction bar, 2 is equal to 8.